This is a revision video for C1, calcium carbonate and limestone. Limestone is obtained from the ground through quarries, like the one in the picture. Limestone is a sedimentary rock, and its formula is CaCO3. Obtaining limestone through use of quarries is a little bit divisive. There are lots of advantages and disadvantages to this process. Quarries are an eyesore and destroy the habitat of many different animals. This is a disadvantage to using quarries. To break the rock, the quarry uses explosives, which cause noise pollution and add dust to the surrounding air. It's also a disadvantage. Lorries transport the limestone, which adds to the traffic coming in and out of the town. Obviously a disadvantage to the people that live there. There is, however, a couple of advantages. Having limestone quarry nearby creates jobs for local people. Limestone is a useful raw material. It is used for making paper, cement, glass, concrete and mortar, as well as neutralising acidic lakes and soils. And then once all the limestone is quarried, the area is landscaped so that it blends in with the natural surroundings. There's another bigger disadvantage as well. With the more lorries, more carbon dioxide is released, which is a greenhouse gas, which then links to global warming. When calcium carbonate is heated, it breaks down in a thermal decomposition reaction. Thermal meaning with heat, and decomposition meaning to break down. The calcium carbonate is heated and it forms calcium oxide and carbon dioxide. The carbon dioxide produced escapes into the atmosphere, and this process needs to be carried out in industry in huge kilns at a very high temperature, 900 degrees C. We can do this reaction on a smaller scale in the laboratory. If we add heat to our sample of calcium carbonate, it will then break down, decompose, leave us the calcium oxide in the tube. Carbon dioxide will flow through the delivery tube and into the lime water. And we know it's carbon dioxide because it turns the lime water cloudy. So normally the lime water is colourless. When you bubble through carbon dioxide, it turns it very cloudy. Now the general reaction for this is a metal carbonate decomposes into a metal oxide and carbon dioxide. Just remember, wherever you see carbonate, it's very likely that one of the products is going to be carbon dioxide. Limestone is used for many building materials. However, it can be affected by acid rain. These pictures show some more effects of acid rain. They can damage tree life, they can corrode buildings and statues. The amount of acid rain has increased due to our burning of fossil fuels. Impurities of sulphur and nitrogen in the fossil fuels react with oxygen in the air when we burn them. This produces sulphur dioxide and nitrogen oxides. These gases dissolve in water droplets in air to form sulfuric and nitric acids. These then rain down onto the land, onto limestone and any building works, into lakes and rivers, and onto trees and wildlife, causing corrosion over time. If the acid rain reacts with the calcium carbonate, it will produce carbon dioxide, a salt and water. Now, this is the case in general when any metal carbonate reacts with an acid. We always get carbon dioxide because of the carbonate, we always get a salt, and we always get water. So for calcium carbonate, If it reacts with hydrochloric acid, it produces CO2. The salt is calcium chloride, and then water is also present there. Now, the salt that is produced depends on the name of the metal in the metal carbonate and the acid used to make it. The first part of the name always comes from the metal, so in this case it's calcium, and the second part comes from the acid used. So because this is hydrochloric acid, it makes a chloride salt, so we get calcium chloride. If we had used a sulphuric acid, then we would have had calcium sulphate. This table gives some more examples of naming salts. It gives you the metal involved and the acid and the salt that is produced. Sodium hydroxide reacts with hydrochloric acid to make sodium chloride. So chloric makes chloride. Potassium hydroxide reacts with sulfuric to make potassium sulfate. Copper oxide reacts with hydrochloric acid to make copper chloride. Zinc oxide reacts with sulfuric acid to make zinc sulfate. Calcium carbonate reacts with hydrochloric acid to make calcium chloride. And then sodium carbonate reacts with sulfuric acid to produce sodium sulfate. It's really important that you try to remember the way that these salts are named. There's almost always a question on naming salts, so the more you practice, the more chance you have of remembering it.